Hi everybody. My name is Max, and I'm very happy to present to you the solution of Team 1 from Technical University of Munich to this year's Data Mining Challenge. This is our team. We are 7 students from different study backgrounds, our skills complement each other quite well. We enjoyed the challenge very much, learned a lot, and now are happy that we made it into the top 10 and are able to present to you our general approach today. So let's start with a short recap of the major challenges we identified right at the beginning. The evaluation by public voting seemed to be rather tricky, as it is difficult to create testing metrics and evaluation criteria if the evaluation is rather subjective, right? Furthermore, there was only limited data provided, as there were only a few features given on all items, as well as only a small overlap of transactional data, which was further also unpersonalized. So that was kind of tricky as well. And further, we decided very early to run different approaches based on different data, different algorithms, to see which ones perform best. And as the metrics to derive weights and scores for each recommendations differ from model to model, we needed to think also of a way of how we can combine these scores in the end, right? Okay, and finally the models as well. So first of all, we went through all available web sources in order to find high quality matches with external data to derive new features, but also get more transactional data. We scraped websites, we merged huge data sets into our existing ones, and we also downloaded book covers we also analyzed. We will come to that later. We use this extended data sets to run several approaches, several models. We display on this slide, and the general structure is as follows. We ran 4 different basis models to create a set of recommendations for each item as large as possible. So also even more than 5 recommendations were created here per item. In the second step, we then filtered out the top 5 recommendations based on new metrics. For example, the book cover, I will come to that. And like create a re-ranking and get out the top 5 results we use in the end, right? So the first 2 models strongly rely on item similarity and are fully based on items features. The first one relies on string matching, while clustering approach uses methods such as SVD and also k-nearest neighbor. With the third model, we basically scraped Amazon and searched for matches for all of our items we have in the data set, as well as in a second step for the recommendations created by Amazon, we searched for matches as well. And we just took them over into our model. In the fourth step, we relied on the transactional data given, but we also extended this data with external data and used methods such as a priori algorithm to create rules. And based on these rules, like items that were clicked, put into the basket, or were even ordered together, we created scores out of these rules. So overall, these models create a large set of recommendations for each item. And what is important to mention is that our models complement each other quite well here. So only 10% of the recommendations available come from more than one model. So even though some models like the Amazon one or the transaction model could not derive recommendations for all items, as we just couldn't find matches, each model was still important to derive recommendations for the whole items data set, right? And because the models created very distinct recommendations. And further, we created on average 12 recommendations per item. As you know, we only need 5. So here our second stage approach comes into play to get out the top 5. How did we do that? We created several features, mostly out of external data, to impact the ranking of the recommendations. The most important feature here was the cover similarity, as we assumed it to have a huge impact on the individual decision-making process. Here we used variational autoencoders to consider visual resonance between input and recommended items. And these second stage metrics led to a re-ranking of the set of recommendations, where we took out the top 5 in the end as our final recommendations. And that's basically our general structure. So let's recap our earlier defined challenges. As evaluation was rather subjective, we very much relied on our personal gut feeling, right? And used several manual sanity checks, checked our recommendations in order to discover remaining problems that are still existing within our models, to implement them right after in our models so they can take care of the problems. And that worked quite well, actually. To extend the limited data, I explained that. We basically used all information available on the web and merged it into our datasets, downloaded book covers and analyzed them. So that worked out quite well as too. How did we combine our models to achieve an overall result? We basically combined our first stage models by using ordered list. So we get an ordered list of results, on average 12 results, and then the idea of re-ranking comes into play, and then we get the top 5. So we didn't really need to figure out a way how we can combine the different weights and scores created by each model, because we re-ranked them in the end anyway. So that was kind of a workaround, but that worked out quite nicely as well. So I hope that I could give you a little bit of insight into our general approach, and thanks again a lot for the opportunity. Thank you so much.